these discoveries opened up entirely new questions. The mode of action of these antipsychotic drugs, and also, as a consequence of that, new hypotheses about the pathogenesis of schizophrenia. The so-called dopamine hypothesis of schizophrenia came up. Perhaps I should say that while reserpine causes depletion of monoamines, the other major antipsychotic drugs, actually the ones that are now in general use, such as chlorpromazine, that was discovered in the early 50s, did not cause any depletion of the amines. So we wondered how that could act. And we discovered then, in 1963, for the first time an effect of chlorpromazine and haloperidol and such agents on catecholamine metabolism, dopamine and noradrenaline metabolism, and that turned out to be in the direction of stimulation. So it was kind of opposite in terms of function to what reserpine did. So on the basis of that and a number of other observations that had been done at that time, we proposed chlorpromazine and haloperidol and those drugs, they block receptors. Rather than depleting the neurotransmitter, they block, and so that therefore the outcome will be very similar whether you give reserpine to cause depletion or you give chlorpromazine to cause blockade of receptors, and that was then dopamine and noradrenaline receptors. And further along, when the studies continued and others came in, it turned out dopamine seemed to be more important than noradrenaline, even if we still cannot exclude a contribution by noradrenaline for this type of action. I would like to talk about this, perhaps our interest in circuitries. We became very much interested, starting out from dopamine as a kind of a platform to see how does dopamine interact with the other neurotransmitters. And of course, in that context, we became very much interested in glutamate. I remember the NMDA receptor had just been characterized, and also PCP, phencyclidine, had been found by Lodge and his colleagues to act on the NMDA receptor in the channel there to block the receptor. I learned from you that phencyclidine is even more powerful perhaps than the amphetamines in mimicking schizophrenia. So there was still another compound that could mimic the picture of schizophrenia. This compound acted on one of the major glutamate receptors, the NMDA receptor. So on that basis we developed a scheme, and according to this scheme, glutamate and dopamine controlling agents in the basal ganglia, and they are antagonizing each other. The basal ganglia then in turn controls the thalamus, could work as a filter, and this could be a very important filter, important for example in the pathogenesis of psychosis, because if this filters too much, then the sensory input will be too strong to overload the cerebral cortex, and that might lead to psychosis. So that was the very simple concept of a circuitry from which we started out. And of course later on, when we went on and started to test it pharmacologically, we found very much support for it, but also it was more complicated because we had evidence that actually glutamate and dopamine can also, under certain conditions, act in concert. So there are pathways where they oppose each other, and there are other pathways where they operate together.